Okay, hi guys. So in this lecture, we'll be seeing acetals and ketals and then hemiacetals. So let me define what's an acetal. So acetal or ketal is just presence of two ethers on the same carbon, and hemiacetal is presence of one alcohol and one ether on the same carbon. Presence of ether and alcohol on same carbon. Okay, so let us take some examples. So as we have seen in the last lecture, if we react ether with in acidic medium, ethers and alcohol will not react in basic medium. This is the rule of thumb. So what will happen is it will take the H plus from here, convert it into ROH plus. Then the R plus would be breaking off, which would be attacked by water molecule. So two ROH formation would be there. If we have something like this is a example of acetal. Two ethers on the same carbon. Then again this oxygen would be and what will next happen? Water molecule will be getting released with the formation of positive charge here. So positive charge here and OH here. Then what next will happen? The lone pair will form a bond between C and O, thereby releasing this H plus. So this will be the final product formed. This is a ketone. So from acetal or ketal we have formed a ketone. Okay, first the hemiacetal formation was there and then the ketone formation was there. What will happen if we have OET on one side and OH on one side? This is a hemiacetal. We have just discussed in the previous example the formation of hemiacetal from acetal. So again it will result in the same product as was in the previous example. Again this is placed in a acidic medium. What happens if we have something like this in acidic medium? What will happen is again this O will attack on this H plus to create a positive charge carbocation here and OH would be formed. So we would have something like positive charge atom here and OH is formed here. Again what will happen is H2O, the OH from water molecule will attack on this to form a OH here, and similarly the history would be reporting on this carbon atom. So we would again have a OH here with the religion of okay. So I'm sorry, this is actually attached on the same carbon atom. Okay, that's why it is stable. Okay, this is the release of this, and again the water molecule will be released from this, forming a ketone. As we have seen in the previous example, in the presence of acidic medium we would have a ketone formation from a acetal to ketone. Okay, let's see this example. We have something like this in acidic medium. So what will take place? What will happen? This would be the final product. I hope you can make this product by using the same mechanism. And if we have something like this, what will happen? Again in the presence of H plus water molecules, water is the solvent. This will react on this, form a positive charge here, and it will be stabilized by oxygen atom. So positive charge is formed here, stabilized by oxygen atom, and ETOH would be released. Again in water is the solvent, SN1 type of a reaction, SN1 similar type of a reaction will occur here to form OH here, and then again H plus would be in the acidic medium. What will happen is this oxygen will again attack on this H plus to form something like this and OH here, and a single bond here. So this single bond will be broken up between this carbon atom and this oxygen atom and this carbon atom. Why? Because positive charge is more stable here than here. It could have broken the bond from either this carbon atom or from this carbon atom. Why is it choosing to break the bond from this carbon atom? Because carbocation stability is more here because of the lone pair, nearby lone pair from the oxygen atom. Okay, so what will happen is we would have something like this. OH is broken up here and positive charge is here. Again the water molecule will attack on it and the formation of ketone will take place at this carbon atom. Aldehyde will take place in this case. Okay, now we have something like this, wherein we have this and place it in a acidic medium. So what will happen in this case is, again the same type of mechanism happens. This bond would be broken up, so we would have something like this, positively charged here, OH here. Again water molecule will act on this. We would have a formation of OH here, OH here. Again in the presence of H plus, it can either break this bond or this bond by acquiring H plus. So carbocation can be either on this atom or this, or on this atom. Let's suppose the carbocation formation is on the first atom. If it is on the first atom, what would happen is we would have something like this as a structure, plus we would have a positive charge here on this carbon atom. And if it happens on the second carbon atom, means the carbocation is formed on second carbon atom, what would have this structure? We would have something like this plus OH. Okay, so if it was the first case, then we have one carbon atom and two OH on the same carbon atom, hence we would have a formation of formaldehyde here. Okay, and again on this, going forward, this again same type of reaction would happen, wherein this will be attached with OH. We will have a O here, H here. Again this will acquire H plus. So either this bond would be broken or this bond would be broken. In both the cases, again aldehyde would be formed. So I suppose there are two carbon atoms left, so two more formaldehydes will be forming, so total 3 formaldehydes if we go by the first case. If we go by the second case, what will happen is on this carbon atom, again an attack of H2O will take place, and again we have a formation of something like this, and again the water molecule will be released from this product, from this intermediate, to form something like formaldehyde here also. Okay, and in the remaining, again we can actually, for this oxygen atom, it will again accept H plus. Again the bond breaking for be from either from here or from here. In either of the cases, either this will be a carbocation or this will be carbocation. Okay, so in both the cases, 2 more formaldehyde would be formed, resulting in total 3 moles of formaldehyde. So either we go from the first step or from the second step, we get the same product. Okay, so please mark this as an important problem for your revision purpose. Okay, so now we have something like, okay, we have seen this. We'll have something like this, OET and OET on the same carbon. Again in acidic medium, what will happen is this ketal or acetal will form this product, and with 2 moles of EtOH. What happens in this case? We have in acidic medium, what will happen? Again there are 3 carbon atoms, so we would get, and this atom will be actually having 2 OH on itself, and these two would be released as CH3OH. So 2 moles of CH3OH would be there, and this would be further converting into formaldehyde or HCHO. Okay, 1 mole of HCHO plus 2 mole of CH3OH. So with this we come to an end of this lecture. In the next lecture we'll be seeing some more of the examples, and we'll be writing mechanisms of the same. So till then, good luck and goodbye.